Let's calculate the net work for each of these examples. If a person drops a 10-kilogram ball from a height of 2 meters above ground, how much work is done? Well, the person's not going to do the work here. Just dropping something is not work. Gravity is going to do the work. So first of all, let's find out what is the force of gravity that pulls that ball downward. Well, let's see. Fg equals mg, which is 10 kilograms times 9.8 newtons per kilogram. It's 98 newtons. All right, how much work is done by gravity, though? Newtons, 2 meters of displacement, and we have to use an angle. What angle should we use? Notice that the ball actually goes downward, and the pull of gravity is downward. So would this be an example of positive work or negative work? It is positive work. And the angle between those two is 0. They're in the same direction. So we're going to get a positive 196 joules. Okay, how else do we know that it's positive work? Because if a ball is dropped from rest, it will speed up. And anytime an object speeds up, the net work being done on that object must be positive. In this case, there's only one force on the ball if we're ignoring air drag. And so the net work is also 196 joules. What if a person lifts a crate up? So they apply an upward force, a force of push, to combat the force of gravity. And if they want to move it up with constant velocity, then they just have to have the two forces balance. But notice that our object, it goes upward. Okay, so the force of gravity on this box is 98 newtons. And the force of the push must have to match that, 98 newtons. The work of gravity on the box will be 98 times 2. But will it be positive or negative? Notice that the force of gravity is directed downward, but the displacement of the box is upward. So does gravity do positive or negative work? Negative. Gravity pulls down. It wants the box to go down, but the box doesn't go down, it goes up. So the effect that gravity was trying to achieve didn't happen. We get negative work there. Now let's find the work of the person's push on this box. They push with 98 newtons. The box travels 2 meters upward. Is it positive or negative 196? Positive 196. Person pushes upward and the box goes upward. what is the net work on this box? 0. The box neither speeds up nor slows down. This time the person's going to apply a constant force of 200 newtons on a 10 kilogram ball. That's more than is needed in order to move the thing with constant velocity. The person's going to actually throw the ball, accelerate it toward the sky. So the work of the push now will be 200 newtons times 2 meters, which would be 400 joules. But the work of gravity here would be just 98 newtons times 2 meters, but it's going to be negative because gravity pulls down and the ball is being thrown upward. So our work of gravity is negative 196 joules. What's the net work now? Well, it's going to be 400 joules minus 196 joules, which is 204 joules. Notice that the net work is positive, which means that our object will speed up. And now we have a little bit of a tricky one here. It's a ball rolling on a 30-degree ramp, and it travels 10 meters. So our ball goes from the top of the ramp to the bottom, a 10-meter path. But what's the force? Well, we know that gravity is going to pull down on that ball. So what component of that goes in the direction down the ramp? That would be what we call FGX. If we can find FGX, then we could complete this problem. So FGX, if you recall from the past, has a formula FG sine theta of the ramp. So our FGX is going to be 98 sine 30 is 49 newtons. And all we'll need to do to solve the problem then is multiply the 49 times the 10, because see, the FGX is in the direction of the displacement. So there's 0 degrees between them two. So the net work then, 490 joules. Will our ball speed up, slow down, or stay with constant velocity? Since the FGX is the only force on the ball, the only unbalanced one, it's going to be speeding up. Because our net work is positive.